So I'm John Vaughn. I've had some people ask me what I mean whenever I talk about the dimension of time, and that's that's pretty simple. What do I mean by it? We take it for granted that we understand time, and we think we understand time, but really time is a complicated thing. And one of the things that really bugged me is the fact that it seems like I'm so somewhat limited in the way that I view the world as a human to view it in a certain unit of time. I've had some people ask me to explain this, what I mean by this, so I'll just spend a little bit of time explaining what I mean by this. Let's look at units of time and see what different units of time that there are. So, we have based on the second as a base unit. The following time units are used and follows: minute, hour, Julian day, week, Julian year, decade, century, millennium. Okay, so here's units of time, and this is cool. And this is why this bugs me about reality. So, I look at time as a unit. There we go. There's my 1 unit of time. Well, what is this unit? Well, for most of reality, what this unit is, for observable reality, is the amount of time that it takes me to really visually process information that I'm seeing. So, if I look back at all these different units of time, what do I really have? I've got a jiffy. I've got 1 second, so I've got a minute. So here's things that I can start to actually begin to understand. So I've got a second. So let's call that my unit of time. So is that now? If I want to say right now, the present, whenever I say what's the present, whenever I look at it and say, hey, is that what's happening at this one particular second? Or do I say, no, actually I want more accuracy. I want to say what's exactly happening at this millisecond, or at this nanosecond, or at this picosecond. Okay? So a picosecond is 10 to the negative 12. So 10 to the negative 12. So that means that's got a decimal right there. Put it right there. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so my decimal was right there at 1 unit, so I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There, that's what I've just done. I've just broken this down into a bunch of time. There's 100,000. Well, that's really a million. So that's a billion. So I've just broken that down into a trillion units. So now I've taken this 1 second and I've broken it down into a trillion units. And what can I do with those units? Well, I can take this nanosecond, and a nanosecond is actually 10 to the 9, so I did a picosecond. So I can break those picoseconds down into even more units, and I can break them all the way down according to the scale to a Planck unit of time. What's a Planck unit of time? The amount of time that light takes to travel one Planck length. Theoretically, it's the smallest time measurement that will ever be possible. Smaller time units have no use in physics as we understand it today. So you can't get smaller than a Planck unit of time. Well, I disagree with that because it's a pretty simple concept that anything you have, if you have that, if you increase it, you shrink it, you make it bigger, and then you have it, then you break it up into smaller units, and then you take that smaller unit, you basically magnify it, make it bigger, you break that down into smaller units. You keep doing that. That's what we've been doing this whole time, moving from here to here to here. We've just been taking a unit and breaking it down into subunits. That's what we've done this whole time. So for you to tell me that whenever you get to a Planck unit of time, there's nothing smaller than that, well, you're telling me that defies logic right there. So what I mean by a time dimension is I'm basing reality on a time unit. Okay, so I look at something and I say it's there. Okay, yeah, this tree's in front of me, this computer's in front of me. But if I really get down to something like a Planck unit of time, I can look at the actual atoms and I can see that, no, you're actually not there. You're actually in a different spot. You're actually not there. So even though I don't see you're vibrating, you're moving, you're not a solid thing. You're shifting all over the place. But I don't see that because I can't process Planck units of time in my visual system. So this whole perception of reality that I have is really skewed because of how I'm looking at it, how I'm observing it. So I can't go just with the visual information that I take in and say, hey, this has to be real because I'm looking at it, I'm seeing at it visually, because at the same time, the things that I can't process visually because they happen in smaller time units, like let's say they happen in a Planck unit or they happen in a attosecond, then I have to somehow account for the fact that that's reality too, because that's really going on. So what's really going on, and these are things that really make me think, and I think this is where people tell me I think too much. I sit here and I can see stuff like trees, I can see houses, I can look at all that. I can look at all that because there's this sun out there and it's radiating its light. But at the same time that it's radiating its light, and its light is hitting stuff and bouncing into my eyes, and I'm able to see it, at the same time that all of that's happening, there's all this radiation going on that I can't see. Just because the wavelength of this is different than what I can see, because I can only see this light right here. That's the only light that I can see in this spectrum, this visible light. But I still have all this other light. I have this infrared light and these radio waves and these X-waves and these gamma rays and this ultraviolet light. I still have all this light that's actually beaconing down. So not only do I have this radiation, I've got this ultraviolet radiation going on. I've got all these devices that are beaconing off all these radio waves and all these radio frequencies. I've got all these x-rays going on around. And besides all that, I've got all this matter that, let's say, I've got this tree, and I know what this tree is made up of. It's made up of these molecules that are made up of these atoms, right? So I've got all these atoms at the same time scattered around in here that I can't see, and I know they're there because I'm breathing them, because they're air. I'm breathing all this stuff. So really, this is what my world looks like. Can't see it because half of it's invisible. My eyes just lie to me, tell me, hey, you can't see this stuff, it's not there, but it is there. I move right through it. You know, on top of that, got all these cool things, these neutrinos, and they just go right through my body all the time. So this is what the world really looks like. Now, are you gonna see this on some TV, on Fox News, or CNN? Nope. You're not gonna see any of that. You're gonna see ads for this, because you should buy this. You should not think about this. Because we only live once. We only live for X amount of time, and we should just work, have a job, get money, conform to society, do what the government tells us to do, and not really expand our knowledge, and we should be happy with that. I can't be happy with that. I've got to think, and I've got to understand. So I'm going to get back to making my railgun, which is a pretty cool concept that I get to design for somebody, and basically all I'm doing is printing out a 3D prototype. So a lot of the parts for the 3D prototype are going to have to be taken from the 3D model that I make, and then actually used to make a mold to fabricate the part out of something else, like the rail system, because it has to be made out of a conductive material. So this is just my little insight into what's really going on in the world, and how the world would be different if we looked at it in a different unit of time. So you always have to do that. You have to look at units of time differently, because not only can we come down here, we can also go past a second, and we can go to a megasecond. It's about 11 days. Or, you know, we could go to a year, or we could go to an Olympiad, or we could go to a gigasecond, which is about 31 years if we go to a gigasecond. And we can start to think and say, hey, a gigasecond is just one unit of time. And that's actually a very, very small unit of time, because you can keep going to cosmological decades, which varies, or you can go to yada second, which is about 31 quadrillion years. So what's the point in all of this? I don't think I really have room to tell you what the point of all this is, but I will try to see if I can do that really quick. Time is very illogical, because if you think of it, you've got this thing that can get smaller or can get bigger, and no matter what size it is, you can look here and you can actually say, hey, you're this big, let's pretend you're this big, and then go that much bigger. Let's do the same thing. Oh, you're this small? Well, let's pretend you're this big,